how fast a person should drive his car so that the red signal of light appears green. Well, it is quite dangerous, but the concept is of red shift and blue shift. Okay, that is Doppler effect of light. So, if a red signal, if it is should appear green, he is moving from higher to lower wavelength. That means lower frequency to higher frequency. Lower frequency to higher frequency is moving. Wavelength being higher, he is moving towards a lower wavelength. So that is what we call it as blue shift. That is what we call it as blue shift. Anyway, we need to find out the wavelength. Velocity we have to find out. So it is lambda dash is equal to lambda 1 minus V by C. So the apparent wavelength should be lower in comparison to the initial wavelength. So now lambda, wavelength of the red color is given, that is red color, he starts to drive. From there he has to shift it to green, which is wavelength of the red color, that is initially he tries to go from red to green, no. So it should be 6200 angstrom, green is 5400 angstrom, 1 minus V. C is 3 into 10 to the power 8 meter per second, that is velocity of light in air. So this is a concept of blue shift, where velocity, apparent wavelength is getting reduced because of the higher speed. So angstrom cancels, 2 zeros cancel. So this is 54 by 62 equal to 1 minus V by 3 into 10 to the power 8. So this comes to this side, V by 3 into 10 to the power 8. This is 1 minus 54 by 62. So this is roughly, if I take 62 common denominator, this is 62 minus 54, 8 by 62. So velocity should be 8 by 62 into 3 into 10 to the power 8. So that will come roughly about, now if I go on calculating this, this is roughly 8 by 64 is 1 by 8 into 3 into 10 to the power 8, that is 0.125 into 3 into 10 to the power 8, that is 0.375 into 10 to the power 8, or 3.7 into 10 to the power 7 meter per second. This is by rough calculation. Answer should be more than 3.7. Hence option C, which is 3.9 into 10 to the power 7 meter per second, is a correct